All right. Let's it's good to see you all today. So a reminder that there are quite a few of you that still owe me this test. So there's this green quiz. So Blake, who's not here, owes it. Ben, who's not here, owes it. Drew, who's not here, owes it. Angela J, you owe it. Angela M, you owe me it. Clay, who's not here, owes it. Ashwin, you owe me this quiz. Cooper, who's not here, owes it. Logan, you owe me this. Grant, you owe me this. Eduardo, you owe me this. Riley, who's not here, owes me. Peyton, who's not here, owes me. Kate, who's not here, owes me. Miwa, who's here, owes me. Lieb owes me. Hannah, you owe me. Olivia, you owe me. Parker, you owe me. Whoa! Thank you. Landon, you owe me. Fiona, who's not here, owes me. Ava owes me. Kyle owes me. And then, is there anybody that owes me any of the other quizzes? Grant, who's not here, owes me work quiz G through J. Cooper owes me G through M quiz. Blake owes me G through M quiz. Cooper owes me G through M quiz. So that's the same quiz, just different forms. So, yeah.
Can I get the notes from yesterday?
Yeah, I'll grab them for you. Remind me at the end of the period, I'll get them for you.
You know, it'd be fun.
All right, so we did yesterday L.
Yeah.
Is that right?
If you didn't do it, I guess.
So let's get L out and see if you guys and girls and any of my friends in here have questions on it. Yeah, what do you got?
19 and 24.
19 and 24, all right. 19 and 24.
Those the ones with the words in it? No, I mean, like, the word problems. The ones on the back. 37, 38.
Okay. Those two, right?
Yep.
All right, so for number 19, let's do this. I gotta pull up my calculator. Actually, I'll just use one in back. Pretty sure you guys know how to plug numbers in. All right, so log of 8431 is 3.926 minus 2x equals 1.3. Subtract that. So 3.927 and then divide each side by 2. So you get 1.313. Is that okay?
Yeah.
Cool. This one, because I'm having an exponent, I can do the log of both sides. And I would choose log base 10, so that cancels. So I get x equals log 0.167. And then just do log 0.167. And get negative 0.777. What else did you see on the homework?
Were we supposed to do it like that, or were we supposed to or could we have graphed it?
You could have graphed it as well, and
Because I saw that.
yeah. And did you find the x component right there?
Yeah,
Is
it's
that
just a
same?
lot of work though.
Yeah.
Plugging it in.
It's up to you. I mean, so you doing it your way is actually going to benefit you when it's on the capstone test because you're going to see that. So you're fine.
34.
34.
Decimals.
Not decimals. Anything but decimals. Log 7.5. And then I have 0.5. 2, 3, 4, 5. All right, so I can do one of two things. I can do the log base on the calculator, or I can do the log of 1, 2, 5 over log 7.5, and just plug those into the calculator.
Oh. Okay. Cool.
2-1?
Yep. 3.4 equals log x. So I want to undo the log, okay? And that's log base 10 because we don't see anything, right? So each side is going to become an exponent. So those cancel, so I get x is equal to 10 raised to the 3.4 power, and then whatever that would come out to on your calculator. It's over 1,000. What else?
So how you set up like 29?
29.
It'd be like log 88 over log 7.
Log 88 over log 7,
Okay,
exactly.
just plug it in. Right.
Or on your calculator, you can go find the log base, but if you see it that way, go for that way. It'll work every time. Any other questions? Going once?
45.
4-5. That one?
Yeah.
Okay. So I could do one of two things. I could bring the exponent back up top, so I'd have natural log x to the 6th. Or, because this is 6 times this quantity, I can divide both sides by 6. So I'll get ln x equals 5. And the undo of ln is e, so make both sides an exponent. Those cancel. So x equals e to the 5th, and just plug that into your calculator.
Okay.
Anything else? We're good?
38.
38?
Oh, never mind. I got it.
Okay. We're good? All right, make sure your name's on that and anything else you might be handing in. Hey, doctor.
Oh, there you go.
So I'll take it right now.
I don't know what it is, but it's been going on.
Cool. Thank you.
Yo, is that your page?
Call Susan Syrup.
Family emergency. I think it's.
Teach us. We're on a movie.
Yeah.
It's okay if you
Talk
say no.
about the
We
goat.
don't care.
We can just watch the Magic School Bus or something.
I love
There should be a Magic School Bus for algebra too. I don't know.
Dude, I would watch it.
Thanks. That's all good. We're renewing our kids' passports.
Oh.
And I signed up on all the documentation, but you know it's the government
It's
in
the government.
control of it. They're like, oh, this isn't good enough.
Uh-huh.
It's like, no, this is notarized.
Okay. I thought it was an emergency.
Oh, well,
That's important.
So my wife's kind of in this panic, going, he's at work. This is what you said you need to do. Oh yeah, but we changed that. When? Like we were just here last week, and you told us that this is what you need.
Nice.
Yeah, thank goodness the federal government's in charge because we're all safer. And that's my civic. And that's on record too. All right. So did I collect all the homework?
I feel like if he's a doctor, he should just wear a lab coat every day. Or scrubs. Scrubs and a lab coat every day. That'd be kind of chill.
Perfect. We're good. All right. Everyone has notes, yes?
Yeah.
All right. So we're getting into solving these, and when we solve them, a lot of times, it seems like it goes real easy, and then if you get your results back on the test, you're like, how did I miss that one? And the reason is, when you have natural log, which is ln, or log, L-O-G, and it doesn't matter if the log is to whatever base, there's something that's called an extraneous solution. What's up, bub?
What's up? I didn't finish that.
Oh, cool. Let me go grab it real quick. You can see it on the far side. Wave to the camera on the way by.
Hey man, you're on TV. Famous now.
All right, so there's something that you get when you solve these sometimes called an extraneous solution. And that means that it's solved nice and easy, but unfortunately, when you plug it in, you plug the number back in, you get the natural log of a negative number or the log of a negative number, which is like a big no-no supposedly in math.
Haven't we done that before?
We've seen extraneous solutions before. There it is. It was just the one quiz, right, Ethan?
Yeah.
Sweet.
Who's the guy next to Einstein?
John Belushi. Huh.
I thought he was a hockey player.
All right, so the first thing is we just have to go back and remember how to condense. So remember, if you have log and log and you're adding it, that becomes log of 3x. Some people prefer it to stay in parentheses. It doesn't matter to me. If I condense this, I have to remember to bring the exponent up top. And so I'm going to wind up with log base 3 of x squared 4. I'm okay with that answer. It's not that pretty. I think a prettier version would be to do it this way. Technically, that's not wrong. And again, some people prefer you put it in parentheses. Okay. Good so far? Oops, got a couple down here too. And then if I wanted to condense this, I'm going to move the exponent up top. And subtraction means what? It's going to be a division problem. So then I'm going to get log base 5 of x squared over 3. And again, I'd probably put that in parentheses just so the grader doesn't think that you're doing the log of x squared and not of 3. This one, bring the exponent up top. So natural log of x to the 3rd times 7. That's messier. I would accept it, but this is the prettier version. Questions on any of those?
Nope. Oh, wait a minute. Oh, never mind.
You good? Yay! All right. Let's see. We want to start solving these. So when we start solving, this is where we want to think, could we possibly get an extraneous solution? And you don't know until you go to the end and solve it. So on this, I have log base 3, so I'm going to make both sides an exponent. Okay, when I do that, those cancel out, and I get x plus 4 on the left, and I get 3 to the 5th power. 3 to the 5th? I don't know. Let's check out on the calculator what that is. 3 raised to the 5th. 243.
243. Is that okay so far? Subtract 4 from both sides, and we come up with 239. And then if I take 239 and I plug it in for x, does what's in parentheses become negative?
No.
No, so that is our solution. It's not an extraneous solution. If it did become negative, this would have no solution to the problem. What does a no solution problem look like when you graph it? Does anyone have any ideas?
It's like
What is a solution when I graph something? Lines intersect. So if there's no solution, they won't intersect.
So they're parallel.
They could be parallel, or like,
Over each other.
or so like, let's say you had a natural log graph that looks like this, and then you had a straight line like this. They will never intersect each other. So that would be what a no solution might look like if you were to graph it. And a lot of times people think that the no solution, it doesn't graph at all. No, it does indeed graph, it just doesn't intersect.
Or if you have the one, like a natural negative and like a positive, so it's like one here and one here. And
Oh, like this? Absolutely, that would work too. So just two separate graphs that would never intersect, don't have a solution. Letter F. Looks like if I have to add 7 to both sides first. What undoes ln? E. Good. So e raised to the, so both sides becomes an exponent, those cancel. So I get x equals e to the 19th. And if you wanted to, I don't know if it'll ask for it or not, but e to the 19th is a big number. I think that's it.
Whoa.
Somewhere in there. Okay. Oops. Bring that down. What's that log base right now? 10. It's base 10. So I'm going to make both sides an exponent. So 10 raised to the and 10 raised to the. Those cancel. So I get x minus 5 equals 100. Oh, here's a quick tip. You get a number this big, I much doubt if you were to plug that big into your original, you'd get a negative answer. So that's why I kind of skipped over it. I also forgot. So this one, x equals 105. If I take 105 and plug it in for x, do I get a log of a negative?
No.
Nope. So that's our solution. So that's the log of both 5x squared and x. Ooh. Oh, this is a classic problem. Just by looking at it right now, what can x definitely not equal?
1.
No, 1's fine. 0. Why not? Why 0?
Because 0 can be in the
fraction.
denominator.
Yeah, so if you look at this, we have to understand that x can't equal 0 in this case. Okay, so that right there, if any of our solutions become 0 for any reason at all, that can't be a solution. Okay, but that's just, I haven't even solved it yet, and I just recognized I had a denominator with a letter, and I know I can't do it. All right, so this right now is log base 10, so 10 raised to the and 10 raised to the. So that cancels, so I get 5x squared over x equals 100. Is that okay so far? Mm-hmm. Multiply both sides by x. Is that okay? Then we have to solve it, and this is taking us all the way back to Algebra 1. So sorry. 5x squared minus 100x equals 0. I could factor out a 5x from both of those. So I get x minus 20. So I get 5x equals 0 and x minus 20 equals 0. So this is where errors start taking place. You get down to this and you're happy because you have two really nice solutions. What did I say in the very beginning about this problem though? X can't equal 0 because if I plug that 0 back into the original, I would be dividing by 0 and that's undefined. So my only solution to this problem is 20. And then I should really double check, make sure if I plug 20 in, do I get a negative exponent? 20 squared is 400, 5 times 400 is 2,000. 2,000 divided by 20, yeah, it's fine. So 20 works totally as an answer. But the 0 doesn't. And the 0 doesn't work because of the original would have given us an undefined term. We good so far? All right. For b is greater than 0, okay, no, we don't have any b's up there. Oh wait, b's are bases. And b is not equal to 1, so we don't have a base of 1. B to the x equals b to the y, so then you could say if I had the same exact bases that are not 0 or 1, that I could set the exponents equal to each other. So I have the same bases, so I can say 2x plus 3 is equal to 4x minus 1. Solve in algebra 1, subtract, I get 2x over here. Subtract that, or add that, and I get 4. So x is equal to 2. Can we have negative exponents?
No. I mean, they have to be on the
Sure.
bottom, so.
Yeah, I could have like 3 to the negative 5th power, which is 1 over 3 to the 5th. So there, when you're looking for exponents, you don't have to necessarily check for an extraneous solution because you're not going to have them. Number 2, I have the same bases, so I'm going to set my exponents equal to each other. So I get 3x is equal to x plus 8. Subtract x. So x is equal to 4. Number 3. I have a base of on one side of 2, and I have a base on the other side of 4. Yeah, I can make 4 2 squared, agreed? So let me extend this page a little bit. So I can go 2 to the 3x, that's totally fine. And this is going to become 2 to the 2x minus 1. Do you agree with that? Now they're the same basis, so I can set my exponents equal to each other. I can distribute there. That's 2x minus 2. Subtract 2x, so I get x equals negative 2. And again, I can have negative exponents, so I'd get 2x to, or 2 to the negative 6 and 4 to the negative 3. Perfect. I love it. It works.
Did you multiply by 2 or divide by 2 on that
I subtracted just,
to get the same bases?
oh, I just converted this to 2 squared, and then that raises it up to that. So
okay.
then you multiply the exponents.
Okay.
Okay, on this one, let's see if anyone catches on to what I did here. Yes or no?
Yes.
0.1 is 1/10.
Yeah.
Okay, so now I can move that 10 up. And if I move that 10 up, what happens? 10 raised to the what?
Negative 1.
Negative 1. Why is it negative 1? Because it moved up.
So
So now I have the same exact bases. So I set the exponents equal to each other. So add 4 to both sides, I get that. So x equals 1. Divide by 3. If you plug 1 back in, you get 3 minus 4. That's negative 1/10. And negative 1 is indeed equal to 0.1. Life going okay? Let's see if there's any more emergencies out of the stirrup household. All right. So this one, we have to use a little bit of algebra. Well, it's all algebra, actually. But your first move would maybe be this. 10 to the 2x is equal to 5. What did I do? Just subtracted 3. What brings exponents down front? Log and natural log. It would be real obvious that we should go log of this and log of this, because that log now is base 10, brings that down front. Log base 10 brings the exponent down front is 1. So I can get this. And then that's going to give me an answer of this. I made it all over 2. And I guess you could on a calculator simply go log 5 divided by 2. And this is about 0.349. What about number 6? What should I do?
minus 4.
Good.
21.
So subtract 4 from both sides.
And then log 10.
Yep. So that'll be log base 10, so I'm just logging on both sides. That cancels, so I get 2x minus 3 equals log 17.
And then
I guess I could say, okay, what's log 17? So I get 2x minus 3 equals 1.23.
plus
And then
3.
add 3 and divide by 2.
4.23 divided by 2.
Rounded to 2 spots.
Nice.
Seem okay?
This whole unit calculator stuff.
For this, I think we should probably, I imagine, until I go and find it. And I was like, wait a minute. No calculator? What do you mean? And if it's no calculator, you just leave it as ln2 plus 5.
Yeah.
Okay, so this one we're going to do natural log because it's e. So the first move on this one, I subtract 9 from both sides. So I get negative 4. Divide both sides by negative 4. Is that okay? If I do the natural log of both sides, those cancel. Natural log of 1 is 0. That works. Oh, we should have seen that originally. E to the 0, 1. Yeah, it would have worked. Am I going too quickly at all?
Yes.
Am I almost? Am I really?
No.
Oh.
Yeah, we're on like the last page, I think.
Last page?
Wait, no. We have 3 more slides. And tell me which one.
Well, I just did that one, so I had 2 more slides.
Oh, last page, yeah.
Poor Sam can't count. Go back to kindergarten. All right, I'm just joshing. All right, we want to check to see if
I
the
need to
x
take
value
first
is
grade
indeed a solution.
For the third time.
So we want to know, is this the solution to this?
Plug it in.
And there's a couple things. Yeah, I could try and plug it in to see if that works. Or I could maybe try and expand this. No, do I expand it? What if I did this? E raised to the, those cancel, so I get 2x is equal to e to the 8. Is that the solution? No, why not? Well, 2 times x is equal to e to the 8. So x can't equal the exact same thing that if I double it is, unless it was 0, but it wasn't. So is this a solution? No. Okay. This next one, we want to make sure, hey, does 125 work? So we could plug it in, absolutely. I could also do this. I can go 5 raised to the and 5 raised to the. Those cancel, so I get 3x is equal to 5 to the 6th power. Ooh, wow. Calculator time. 5 raised to the 6th power is 15,625. Divide by 3. 5208.3 is 52.083.3 the same as 125? Not this week. That's not the solution.
Maybe next week.
Could be. We'll look forward to it. Ooh, look at this. Is natural log 6x equals 4 is the solution e to the 4th over 6. This one, I might choose to plug this in. So I'm going to plug that in right there. So I get natural log of 6, and then e to the 4 over 6. Is that equal to 4? Well, those 6's cancel. Natural log of e cancels. So I get 4 equals 4. Yeah, buddy. That is a solution. Okay, that one I chose to plug in rather than solve it. I could have solved it as well. Last slide, right? Okay, so again, this is talking about the extraneous properties. So we should take a look at this, say, okay, I know if I condense this, I'm going to wind up with this. Is that okay so far? I just condensed it. If I don't see a base of anything, it's 10 raised to the. So that's going to give me 5x, x minus 1 equals 100. Algebra one time. 5x squared minus 5x minus 100 equals 0. Divide everything by 5. If I factor that, it's going to wind up being x minus 5 and x plus 4. So my solutions look like x equals 5 and x equals negative 4. Now what did I say in the beginning about logs and natural logs? Can I take the log of the natural log of a negative number? No. Which one of those would make my original have a negative number, log of a negative number? Would 5? 5 times 5 is 25. That works. 5 minus 1 is 4. So the 5 works on both. If I take the 4 and plug it in, whoops, that should be a negative 4, excuse me. 5 times negative 4 is negative 20. It doesn't work there. And log of negative, yeah, that doesn't work. That's an extraneous solution. So I have a solution only of 5. Thanks, brother.
Peace out, Joe.
Yeah, buddy. Look forward to it. Okay, so we had an extraneous solution. So if two solutions showed themselves, one of them doesn't work in the original because it gives you a log or a natural log of a negative number. This one, let's put them back together. What should my base to both sides be to get rid of the logs?
Log 10? No, I mean...
What?
3.
3. Yeah, 3 raised to the 3 raised to the. Those cancel, so I get x squared minus 2x equals 3. Agree with that so far? X squared minus 2x minus 3 equals 0. So I get x minus 3 and x plus 1. That's factored. So I show that x equals 3 and x equals negative 1. Do either of those give us a negative log?
Yes.
Yeah, the negative 1 does. If I plug the 3 in, it works on both. So here's my solution. That's not. That's an extraneous solution.
Maybe it just worked out too hard in the gym and strained all its muscles.
Yeah, it strained it. This one, if I condense it, I get log of x over 3 equals 1. If log's sitting there by itself, it's going to be base 10. Those cancel, so x over 3 equals 10. X is equal to 30. If I take 30 and plug it in, do I get a negative in front of the log? Log 30, no. No, that works. So it has one solution. And then last problem. Same bases, so I'm going to put them together. So log base 2 of x, x plus 6 equals 4. What's my base on this one? 2. So both sides are going to have a base of 2, and we raise both sides to the exponent. Those cancel, so I get x squared plus 6x, and then 2 to the 4th, 2, 4, 8, 16. X squared plus 6x minus 16 equals 0. X plus 8, x minus 2. That factor right? I think.
Yes.
So I get x equals negative 8, x equals positive 2. Do either of those give me a log of a negative?
Yes.
Well, the 8 definitely does. Does the 2? I get log 2. No. 2. No. Works. Perfect. That's it. So double check your answers. Make sure you don't come up with an extraneous solution. If you come up with one, that's fine. Just make sure you label that it is not your answer. And we are on worksheet L. Is that right? M? Let's see. M. All right. Worksheet M.
That'd be an L if we had to do L.
Hopefully those who are absent watch the video. I guarantee some of them will show back up tomorrow. What did I miss? Did you watch the video? No. Then they wouldn't hear me rant.